here we have this integral. A pertinent question is always what to do, how to proceed. Usually, if you know that the integral that you have is an integral where you apply the antiderivative, if you know this beforehand, then you can just apply the antiderivative. If you know that you need to integrate by parts, then you know how to integrate by parts, or by substitution, or this or that. But if you have something that is just looks like this, and you don't know which method you would like to use, then probably you would like to make some observations first before you make any decisions. And so the observation that we would like to do here is the following. Just by looking at the function, we see that there's a composition of two functions. There's an outside function and there's an inside function. And this composition is being multiplied by a whole different function. So how do you relate these three? The answer is fairly simple. This reminds me of substitution, integration by substitution, where we look at inside functions. We just set u to be the inner function. And then we just proceed and hope that it works. But this is not productive because we need to know how to proceed first. We need to know if this will work or not. And I can verify to you that it will. The only thing you need to check is that the derivative of the inside function, this is the inside function, its derivative is already there in the expression. And now I ask you two questions. First one is, what is the derivative of cosine? It's sine, right? The derivative of cosine is, it's not sine, it's negative sine. You forgot the minus sign. Yeah, I forgot the minus sign. Everybody forgot the minus sign. Anyway, enough of the jokes. So the derivative of the inside function is in our expression. Then this should be more than enough. Here's why. So we proceed normally. We get du is equal to derivative of cosine is negative sine of x times dx. So the rate of change of u is minus sine x times of the rate of change of dx. That's what it says. So in this case, if we would like to replace dx in our integral, then we would get minus sine x on the bottom and du on top. Just solving the equation. Okay, then this is I. Then I is equal to the following. We have sine of x, and then ln of cosine of x, which is u. But then instead of dx, I will write du divided by by the sine of x. So this is what I will replace du with. I do like this. And it should be fine because it's just an equation. I'm just substituting values or expressions inside. And then it's amazing. Sine of x cancels out with sine of x. And I just have an integral that looks like this. So it's a negative integral. There's a minus sign here. And I have ln of u. And I have a du on the right. So in this case, if you know how to integrate ln of u, then this should be fine. You should proceed by parts. So you would choose Okay, this is a bit of a hurdle for me because the definition for integration by parts is this. But then we already have u. U is reserved. So maybe I'll use w. I hope that's okay with everyone watching. So this is integration by parts. I will choose w is the term which we take the derivative of. Clearly, you don't want to integrate ln, so you take the derivative with respect to ln. And as for the part which you integrate, then this will be your dv. This will be your, yes, it will be your dv. It's ln of u, so it's going to be du. And so if you take the derivative of ln of u, you get 1 over u. And if you take the derivative of du, you just get v is equal to u. Plus a constant, yes, but just forgive me for the time being. I'll add the constant at the very end. Okay, and now I can substitute. Now this is a negative integral, so it's the negative of all of whatever will show up right now. We write w times v, so w times v, u times ln of u, minus the integral of 1 over u, which is, this is dw. And then you multiply dw by v, which is u. So I multiply by u. This is nice. Of course, don't forget, it's 1 over u du. Just for the sake of preciseness. So you need to take care of the chain rule, just like we were doing here. But I made a small mistake, apparently. Now I'm not too careful with the evaluation of this integral because it's not the core focus of the exercise. The core focus is really to be able to make the right choice for integration. But then when you do that, you get u times ln of u, negative of this, minus the integral of 1 with respect to u, which is u. Maybe I'll factor out the u. I'll get ln of u minus 1. And since there's a minus sign on the outside, maybe I'll write 1 minus ln of u. So I just switch the integrands. But then I would like to have my final answer in x. So u is equal to cosine of x. Therefore, I have answer of cosine of x times 1 minus ln cosine of x. So it's two integrals in one integral. It's very interesting. But then, this is how you do it. This is a bit standard. This is one of the standard integrals that you'll see. And as for the first one, you need to make the observation. You need to be very careful when you make the observation in order to proceed correctly with the problem. So that is what you need to do. Okay, almost. So I forgot to add a plus c. And so this would have cost me to redo the whole video all over again. So that would be very unpleasant to do. And for you, if you forget to add the c, you'll also lose points. So that is unfavorable for you as well. So the lesson learned here is to not forget the c. So this is it.